So in చెప్తున్నానండి last time. Well, supposed to cancel the class today. But తప్పదండి. So let us start with the production process management. I think so it's going to be kill you the basic level. But one of the most important topic for the Docker and Kubernetes is process management. So DevOps. The next session 8. 9. So process management. The process management. The process management. This is one of the key module. Every DevOps engineer should be aware of that. Okay. So what is a process? Why we need a process? How the process are going to impact the execution of your containers? Here, my explanation is not the containers, but you should understand the how the process are going to elevate the importance in the CI/CD pipeline. You please try to understand carefully. You know, program generally, what is a program? According to your basic knowledge, what is program? So program is nothing but a collection of statements, or collection of code, like it's a kind of code actually, right? It's a collection of statements or a code. So while you are writing the program, this code is going to be perform a task. The task is nothing but execution of. So it means the task can be anything, right? It can be a calculation, it can be a kind of event. It can be anything. Okay. So when the tasks are executing as a program, the tasks are collectively run inside the application. When application is running, background program is running, isn't it? Program is running. Whenever program is running, internally operating system create the process actually. So process is nothing but instance of running program, instance of running program, instance of running program, instance of running program, instance of running program. As we know that Linux is a multi-user, multitasking operating system, right? Multi-user, multitasking operating system. What do you mean by multi-user? Huh? Multi-user in the sense more than one user going to connecting to this operating system, and operating system is going to share the resources of the server to multiple users. You should say, right, generally multi-user in the sense you generally people say like more than one user, but that is not actual meaning. To be honestly, in the server side operating system, this is the where your kernel is playing a vital role in the Docker and Kubernetes. But general people may not looking at that internals, blindly fire the command like a ps command, kill command, something like that. What I'm trying to say, at the kernel is the heart, very well. And don't try to ask me kernel architecture at the server-side operating system. This is completely a big game and big concept. For you, it's not really required. So in the data centers, a big servers are racked. Those servers are going to be scaled in a proper way. We will discuss in the EC2 environment. EC2 definitely we have to learn it because you are managing the EC2 servers, right? That's why there our views and our exploration will be changed. But as a beginner in the Linux level, you don't need to talk about that much level. But kernel contains what? Kernel provides lots of resources, like taking the resources from the CPU, memory, and disk. These are the three top daemons for any operating system, isn't it? The CPU, memory, disk, memory, and disk. The CPU, memory, disk. These are the three fundamentals. It means when multiple users, again I'm repeating, if you feel bored, you can leave it also. Because the process management, I can't change my explanation. According to me, I know the value, right? If you really like it, you can, otherwise you can enjoy your time, guys. Even Amrit or whoever, right? So there are multiple users are there. Multiple users in the sense at a time, more than one users trying to access the resources of the kernel. That is called multi-user. Multi, know that, don't say like more than one user is connected. That's a that's a common definition. It's not technically. Technically, what you have to say, the CP, like kernel is going to share the same resources to the multiple users at a time. That is called multi-user operating system, right? So the main objective here is in the distributed operating system or in the real-time operating system, the main duty of server is your CPU should not idle. Generally, the heart of the entire application is CPU only. CPU should not sit idle. That is one of the main important point. CPU should not sit idle. Should not sit idle in the sense what? CPU should always engage with the tasks of the applications, right? It should always engage. It should always take the task and going to be executed, right? If CPU is not doing any work, what happens? Your tasks are going to slow down. That's why the main design of the multi-user operating system, even clusters, is your CPU should always be busy, right? That is the main agenda, right? Okay, how the CPU is going to be busy? That movement, the first of all, you need to understand a concept called, for example, in multi-user operating system, you are saying like more than one task, right? So you're saying like a task one is given by the programmer one or user one, task two, task three, task four. Like you're giving task in the sense simple, like you open the notepad, immediately you switch to the browser, immediately you play the video, immediately you can see the some X movie, or you may be called to your friends from via WhatsApp call. We do multiple tasks, right? Whenever multiple tasks are submitting to the operating system, so these tasks, right? These tasks are going to hand over to whom? CPU, right? Who will submit it? That's why here these tasks are submitted by the user to the a process scheduler, right? You have to note this point, right? Process scheduler. The scheduler, you know that generally scheduler is going to schedule the call, right? Hmm? Process scheduler. Generally, scheduler is nothing but schedule the call, schedule the meetings, right? So process scheduler is looking at the process queue, right? Process queue. Generally, this is main key component in the server-side operating system. The server-side operating system is going to have a separate program called scheduler. The scheduler is going to talk to the CPU based on the how many number of jobs or how many number of tasks are entered into the process queue, right? Just like if you go for a movie, you have a long queue, right? So each and every person is a task. Each and every task is a process. Each and every process is handled by the one people, right? He engages the uh, right, engage the line. Who engage the line in the sense we go one after one, one after one, one after one, right? That's all the tasks are handled by the CPU when all the tasks are enter into the queue, right? Process queue, right? The process queue is handled by the scheduler. But instead of saying the scheduler, scheduler is going to decide actually. Scheduler is going to decide which process is going to be picked to the CPU. CPU scheduler is giving a signal to the CPU, right? Go and pick it up, right? How? How it is going to be picked up? That's why inside the process queue, all the process queue, like for example, if you are take the theater example, now you are inside the queue. When you close to your ticket booking counter, the guy is going to give the ticket for you, right? The ticket is an entry inside your theater, right? That is called, we can call as a process control table. Process control table, right? The process control table. In the process control table, the CPU maintains all your process in the form of IDs, right? That's called PIDs, right? Process IDs, right? So each and every task is having its own ID. That's called PID, right? This PID is one of the great feature of the namespace concept in the entire kernel, right? So kernel contains the two topmost features, namespaces and C group. Because of the C groups and namespaces, the whole Docker and Kubernetes is going to decide it. Again, I'm telling you, if you feel the commands, that is your immaturity. If you feel my explanation or my execution become like a command in the sense, you are technical fools. Maybe even if your heart is going to be break, I never mind it. Because a system engineering is not something like how you thinking about. System engineering in the sense you should understand how internally it works. That is the power of DevOps engineer, right? A DevOps engineer should understand the system If you understand the systems, obviously the problems will be encountered at each and every dimension of the application. That's why when you get the production error, production bug, there you can see the hell of the debugging, right? Troubleshooting, right? Most of the programmers like maybe Amrit, maybe he may be always focusing on the code. That's not, maybe my DeepSeek or maybe my ChatGPT, maybe my teams will work on it. But in the tuning level, performance tuning level, you need to deeply digging why the application is sluggish. They'll ask this question, why my server is so sluggish? Sluggish in the sense slow. Why server is slow? Then you have to think about parameters, right? How can you think about the parameters? How can you think about the parameters if I don't understand my system? That's why your super brothers, super sisters who are working on the production, they will explain you the troubleshooting techniques to you, right? If server is goes down, first go and see these parameters. Identify CPU is idle or busy. If the CPU is busy, what is the context menu? Context switch. In the context switch, how many number of processes running? Which process is going to take the highest memory? Which process is going to take the highest disk? That is where you have to troubleshoot, right? Simply PS command. Externally, that is not a good deal to understand the troubleshoot, right? So how can you say my memory was full? Anyone? Maybe last 20 years and 50 years onwards, the entire universe is using the computers, right? As a computer people, as a computer engineers, as a professionals, as a regular users, according to your basic knowledge, according to my dummy knowledge, what is the meaning of my memory was full? Anyone? Including online and offline?
When the memory is full, the computer will be like process will be stuck and system will slow down. We can
What is
observe with the task manager.
okay? So memory full in the sense what? Memory full in the sense what?
RAM will be completely
RAM is
occupied by
very
processes.
like it's occupied with a more number of tasks, right? You are trying to say, right? Okay. So generally, you take like jumping of calls between a stack to memory and memory to stack. So I think so. Mr. Amrit is a good person here to talk about this concept. Mr. Amrit, with your acceptance, maybe you already written a Java program, Java classes. Your class contains the objects as well as a stack, like a local variables, static variables, instance variables, right? So do you know how this memory map was going on that? So if I say like this, beginner like you, obviously blast. What nonsense Srinivas is going to talk. So what I'm trying to say, in a simple way, my operating system or our CPU should pick your task. If the CPU is not picking the task, if the CPU is not picking the task, your application is not executing in a simple layman standards, right? So that's why namespace. How can you say namespace? There are 7 namespaces given by the operating system, not for your right. Docker and Kubernetes. Again, I'm telling you, entire Docker Kubernetes running on the 2 powerful concepts. What is that? Namespaces and C groups, right? What do you mean by namespace? Namespace is nothing but providing some kind of resources to you, right? Resources is a process ID. In this context, we are going to talk only process only. Apart from user, apart from there is a mount, apart from there is a network, apart from that there is a domain, apart from that there is a one called as a ch root, a separate jail, jail, generally, jail. Jail, that normal criminals are going to stay. Jail. So in jail, there is a separate jail or individual, like maybe they keep all persons into one room. Depends on your task which you performed in the outer world. Like if you are so dangerous, they will get a separate room, right? Just like they treat as a delegates, right? The same way, like some programs require a small memory, big programs require big memory, right? In the sense, some process will take too much memory, too much disk, too much process, right? Who will decide it? What we decided? That's why scheduler will talk to the CPU. Hey, one of the few of the people are joining the process queue. I'm giving IDs for them. You please pick the IDs and start. Internally, CPU takes some algorithms. These algorithms will discuss in the Kubernetes and Docker. There, they'll kick your face logically if you keep your experience. But if I say, you will feel bored, right? So they'll ask this question: do you know round robin algorithm? Maybe Java programmers are very, very, uh, um, they may know that regularly, like how they design the program. Have you learned the Selenium, right? In Selenium, there is one Java pattern is there. Um, one of the pattern called as a page object model. You know? Okay. Don't know? Okay. If you have free time, open the Gang of Four principles. There are 23, 24 design principles are there. That is Java is going to be support. Why I'm talking this? Every process in the CPU or every process has its own PID, right? Now, here PID, process identifier. Please note it down. PID, right? Process identifier, right? Process identifier. PID, right? Maximum PID is a limit between 1 to 65,535. Whenever it reaches to the 65,536, automatically according to the state, algorithm, it will start the cycle and it will generate the new PIDs. And here, every process contains a name also, process name, depends on your execution. For example, I'm running a Java. Java has its process name. I install one Nginx. Nginx is a process, right? I install the Docker. Docker itself running as a process, right? Everything is running as a process. That's why if you open your task manager, see the processes, right? These are all processes currently running in the Windows operating system, like Notepad, Paint, Zoom, everything, right? Simply whatever program you are running, whatever your application is running, internally it is called process. Simple. These processes are distributed by whom? Process scheduler. To whom? CPU. Based on the priority. That is one of the biggest technical sound. Who are working on SRE engineers and performance engineers, performance testers, who are designing the reliability, scalability, they will treat this concept very, very seriously, right? But you are a beginner, simply say, my CPU will take care about it. My CPU will take care about it. So here, whenever the process is enter into the process queue, there is a one process life cycle is there. What is that? This process life cycle in the sense, when you go to the Docker, we'll discuss Docker commands, Docker PS, Docker start, right? That's why, again, I'm telling you, Docker is nothing but process management. If you go and explain it, if someone asks this question, my Srinu sir explain in a single statement is, Docker is nothing but process management in Linux. If they have any doubt, you please refer my name and he will educate you. Yes, you can say like that. But I'm not joking, very serious. I'm very serious right now. That is one of the namespace is a PID. Sir, how can you prove it? Number of namespaces? Cool. Let us start. Technically, we'll prove it right so that you'll get more understanding. Easy way. Because that concept is very, very important to the Docker concept. Best example, if you take like Shiva is one process, Harish is one process, Srinivas is one process, Tejaswini and Droid, and online 10 members, right? Maybe 10 in the sense, 8 members. 2 members is me and one more guy. Monitor. QH is always monitoring the faculties, whether faculties are dancing or sleeping or commenting like this. This is called scheduler, right? Scheduler is going to schedule the timing to the each and every faculty. That is called, he is a scheduler. I am a CPU. You are the process, right? Clear? So now, how much seat you want? Now you are a smart, thin boy. That's maybe a regular chair is enough. Suppose I am a shout. I'm a bigger fatty boy. Then normal chair is not enough. Then what I need to do? I need to arrange the big sofa, right? So big sofa is nothing but big space. So that's why how many tasks enter into the queue, your scheduler will decide it. This much CPU I have, this much memory, this much process I have, not process, this much memory required for this process, right? That is called round robin algorithms. We have some algorithms are there, right? Forget about algorithms, right? But how to pick it up? Priority, right? Priority. How can decide the priority? High priorities, low priority. We'll discuss. In Linux, there is a concept called as a nice concept. What is that? Nice, renice. Nice and renice are the two powerful commands to decide the priority, right? Generally, priority event under some people say very feel right. Suppose if your closer friend is came into your party, if you didn't looking at, if you are not consider him, you feel bad. You didn't recognize me. You are not giving a priority to me. Why? Because that moment, maybe other delegates came to the party. So he may be going to ignore it. Priority. On what basis Mr. Harish is going to give the priority? Right. So that's a task, execution speed, how much disk space, how much memory required is a calculation internally. Based on that calculations only, it will going to pick it up, right? While picking up, what about other friends? They should not leave the queue. They should not leave the party. They should also wait for your signal, right? That's why once the process is enter into the queue, you should know that. That's called process states. What is that? Process states, right? Process states, one of the top interview questions, right? In the Docker as well as the Linux, you can't escape from this. Real DevOps engineer, real company people, no fake guys, definitely will ask this question. Explain the process states, one of the damn questions, right? So when the process is entered into the queue, it is called as a submit actually. What is that? The first state is submit state. Suppose you join in the you join in the like queue to get the ticket, right, to get the movie ticket, right? So now once you join in the queue, that is called submit state, right? So submit in the sense your queue is slowly moving, right? So before queue is nothing but last in first out or first in first out. First in first out. First in first out. Okay, if you enter into the theater last in first out, like whenever the movie was over, last in first out, that is called stack, this is called queue. These are the two data structure in the programming world. That's a data structure. The process control is a data structure which maintains how the process is in, how the process is going to out. Okay, that's why once the process is entered into the queue, that is called as a submit, right? So okay, now submit. Now I'm moving. I'm ready to take the ticket. So now the queue is moving. The task is going to be handled to the CPU. CPU is going to looking at you, right? Who is come to me? Who is come to me fast, right? That movement, if you are not ready, he cannot pick. That's why the submit will be slowly changed to the ready state, right? When the state is ready, if the CPU is picking up, then it's called as a running state. Running in the sense what? Your CPU pick your program like a calculator, running the movie, whatever it is. Now it is starting running, right? For example, you are going to taking the ticket. Still, the counter people not like just giving in a fraction of seconds. Suddenly he stopped you, right? Why? Because suddenly he got call from the management, or maybe a management recommended candidate came and he is recommended in tickets for him, right? That moment, what happens? He stopped the queue, right? Why? Because he is the main person to him, right? That's why during this execution of your task, still not yet over. During execution, suddenly a new high priority task is entered into the queue. I should not abort you, but I have to keep alive. At the same time, I should not disturb this high priority task. That's that movement. They keep all tasks into waiting state, right? That's called context switch. According to the CPU point of view, Switching between one process to another process during the execution is nothing but a context switch. Context switch, right? So during waiting, uh, you guys are maybe you can talk to you. Maybe in the queue, you have a predecessor, you have a successor, you have a predecessor and successor, right? In a theater, if you take like a row, who is a successor, who is a predecessor? Are Baba, both 6 members book the tickets. Like chair one, 2, 3, 4, 5, 6. Just assume it. We got I number. I throw. So there is a 5, 6 tickets we booked, right? Okay. Now I enter into the queue. Queue in the sense what you said? First in, first out. Okay. I go to the first chair. Then I sat. Next she sat. Then he. Then you. Finally, I'm watching the movie. We are watching the movie. Once the movie was over, who will exit first? Sixth ticket person. Till that, what? You should wait. You should wait. You should wait. Finally, I have to. What is this actually? Why should wait? Why should wait for? Why can't you go at a time? All guys are. Why can't you move? But we can't move it, right? Why? Because there is no space actually. That's a major problem, right? Even though there is a space, we should follow some conventions, right? Ethics, something like that. But according to CP, what is ethics? Bullshit. What is ethics here? According to CP, what is ethics? Ethics is nothing but, hey, I need some time to switch from one process to another process. During switching, dependency concept is there. For example, we are all belongs to same family. We enter into the theater at the same time. We should exit from the same time. And finally, we pick our family members. We'll take the car. We'll go outside. Till that, we have to wait or not. That same way, once the process are enter into the queue, the process has its own child. The child has its own parent. Parent-child relationship based, your queue is going to run it, right? That's called PPID. What is that? PPID. PID, process ID. PPID in the sense, parent process ID, right? PPID, right? Now you have to ask questions, right? Sir, you form the relation with the family. Now he's the like a boy, is the person, and he's finally, I'm just like a something bigger than you, right? Then you can treat me as a what do you call, according to the process point of view, I'm a unit D, or I'm a super mother to all of you. I'm a super brother, right? So I'm a supreme guy to you. All you are inherited from me only, right? All you are born from you only, right? That's why whenever system is booted, when the system is booted from the power on to the till prompt, kernel is loaded, right? Once the kernel is loaded into the memory, first process will be created called as the system D. That is called 1. PID of system D is 1. One of the top entry questions that is called super mother, right? So please note it down with the 10,000 font size. So what is a supernatural process for entire applications in the CPU or server operating system is system D. Earlier it is called as a unit D, old kernel operating systems. Now they call it a system D, right? System D. System D. That is process ID of the system is D as always is 1, not 0. Is 1. You cannot terminate. You cannot terminate, right? That's why come back. Okay, now you are in the queue. Submit is okay. Ready state, running state, waiting state. So now you are waiting. Suddenly, high process is picked. Now CPU handles successfully. During that, you have to wait, or you may be die. You may be die in the sense you may be kill it, or you may exit from the queue, right? Then CPU looking at who is the next to me, right? It will pick it, right? So when the waiting is over, again it will looking at who is in other ready state. It will pick it up and it will start executing. And once the task is done, it is called as a complete. What is that? Finally, complete. Complete in the sense, task is executed successfully by the CPU. When the task is executed successfully, the process will be removed from the process control table. Then process queue is empty. then scheduler will give the signal to the process CPU is already the task is completed. Wait for the next turn, right? This is called process states actually. The same thing we'll discuss PS, Docker PS, Docker start, Docker restart, Docker kill, Docker RM, right? This is nothing but a process states. Let us go and connect to the go to the AWS management console. So got it? So supernatural mother process is initd or systemd. Systemd is the root process. PID of the root process is 1 actually. So this we cannot terminate, right? Now process are represented with the PID. PID is a unique number. And every process is having its own parent called PPID, right? PID, PPID. To see the process of your current terminal or current user or current program, there is a beautiful command called as a PS, right? PS command. PS. What is the password? Password is secret, right? Hmm? Encrypted. So process control table, process queue, process scheduler, context switch, initd or systemd, and PID, PPID is most important, guys. And there's some proverbs I should not speak in public platform. So out of the classroom, I will speak some proverb. So it will directly touch you, right? So what is the meaning for that? So PS over. Simply open the terminal, PS. వాడికి ఏమర్థమవుద్దో వాడికి తెలియాలి, చెప్పినోడికి తెలియాలి, విన్నోడికి తెలియాలి. PS, okay. PS minus E over. Kill over. P kill over. Kill all. Nice. Yes, there is a command, man. Kill all. I'm not joking you. Kill all. Even P kill. PID off. PS tree. P map. Nice. Re nice. Over. దిస్ ఇస్ కాల్డ్ ప్రాసెస్ మేనేజ్మెంట్. పొలోమని వచ్చేస్తారు ఇంటర్వ్యూకి. ఇంకా డాకర్లు కూర్చుని నాలంటూ కూర్చున్నాడు అనుకో, ఓకే, టెల్ మీ వాట్ హ్యాపెన్స్ వెన్ ద ప్రాసెస్ ఈస్ టర్మినేటెడ్. బ్రహ్మానందం అంటే ఎవరికి తెలుసు అని. సో 065468. All right. Launch instance. But do you find any technique to launch these instance quickly, effectively, without every time open and click on next, 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 next? I feel bore. Anyone? Hmm? Number of instances one, and let me go with the key pair. Now, did you try this answer? In the last week, I gave this question for you, right? Without SSH keys, how the EC2 instances are connected? How you are trying to connect the EC2 instance? How? Any reason? Akhil? How it's possible? How it is possible? So without key, we are trying to connecting to the EC2 instance, right? How it is possible? So first let me go to this EPS. What is this? Hyphen A. What is this? So because of the PID namespace, the containers are creating, right? And container has its own ID, not creating. So container has its own ID. Here we call PID. There we call as a container ID, right? DevOps ఏముండదు బాబు చెత్త if you know the Linux. So go back, then try to connect. So EC2 instance connect. So first and foremost key point is how can you say, sir, there is a two top entities supported by the Linux called, there is a beautiful command, ls, ns, looking at here. See, ns, namespace. What is that? What is that? ns stands for, now see, now only I prove. What is this? Okay, next. Kubernetes namespace in the sense your area, you have your own chair. Developer has its own namespaces. Within the namespaces only, I will allocate the resources. Don't come out. Don't come out of this room. I have created a dedicated enough resources to you. That's it. If you want, you can claim me. You can ask me, hey, I want more CPU, more disk, right? Our namespace is a small concept derived from the long years, right? You got it? Now people say like Kubernetes namespaces. Are Baba kubectl create ns, one command. Automatically namespace will be created in the cluster. But finally, back to the kernel, and kernel is going to supply one namespaces, right? So that's where namespaces, right? That's called core. Now, if you go there, what is the command? lsns. See, looking at C group, PID, user, UTS, IPC, NET, mount. These are the predefined namespaces. C group is nothing but going to control the resources of the CPU. Namespace is different, C group is different. Namespace telling that, best example, if you join in the session as a student, what kind of resource you want? A mentor, LMS portal, right? A kind of room, a URL, if you are offline chair, AC, something. That is called Whenever you create an application, whenever you join as a user, the Linux is going to create some namespaces. Every application should have a PID. Every application should be connected to the network. Every application should have some volumes. Every application should have a domain. Got my point? So these are all namespace, isolating. Your chair is different than him, right? Your chair is different, his chair is different, right? Why they given a row? Why given a number, right? Why can't you take all the person, keep in one single place? It's not possible. Sit in the same room, take the different spaces, watch the same movie, right? Watch the same session, right? That's called. So while watching this, how much seat you occupied? That is called C group, right? C group, right? That's why ls-ns is the most powerful command to display it, right? Don't ask how to create the namespaces. You ask me at the Docker. There I can explain you more depth commands. Okay. Next. And one more thing, what I said, the supernatural processes, PID, like, initd or systemd. How can I? There is a beautiful command called as a PS tree. PS tree, right? Display the tree of process. Display the tree of process. Looking at PS tree, if I give an S, you'll get one. There is command called what is this? So initially this is called systemd. Not don't looking at here. This is the initially it start from the systemd. If you want to see the process ID of that, there is a beautiful command called PID off. What is that? PID off systemd. What is that? This is 1. So if you want to see the process ID for the particular process, PID of process name. So PID of the process name is predefined process is systemd. Init D. D ends with a daemon. So systemd, ATD, SSD, D in the sense background, daemon in the sense ghost. Normally, can you see it? That's why we can call invisible. That's why process running in 2 ways: foreground, background. What is that? Foreground and background. That's why there are some background services always required to be run here, right? The background service, for example, heartbeats. Can you see it? Whether you sleep or whether you fight, it's always continuous, right? That's called, according to technically, operating system says that those are called services. What is that? Service. That's a service management. One of the top module. Everyone should know this. How to start the services. Generally, systemctl start service name. Systemctl stop service name. Systemctl restart. Systemctl like enable or disable or daemon reload something like that. That's a process is different. Process is different. Service is different. That's a process management, service management. You have to learn it right. No option, because you are going to install the software as a services. You should know how to start the service, right? Services is always running in the background only. If you stop the service, what happens? Your application can't work out. For example, if my heart is stopped, gone. Main function is not working, then I'm going to be leave from this universe, right? The same way. Got it? So what is the differences between a process and service? If someone asks you, process can run in both foreground and background, but services can only run in background. And such services are useful to run your internal applications like Nginx, Docker services, HTTPD, SSH, right? SSH is running as a daemon only, right? That's why you have to understand one key question is types of types of processes. That's why I feel a kind of hesitation when people say like commands. Arey Baba, Linux is not a command, man. Linux is a software. How you learn the Java, how you learn the Selenium, and how you learn the some kind of PHP or Python. Linux server is a software, not like a command. Like what you are learning in Java, you learn oops, right? Right. Here also, what you are learning the Linux, you are learning the kernel modules. So, so types of process. There are three types of process. Now, hope you enjoy it, right? One is Akil, you know, types of process. Orphan process, zombie process, not joke. It's serious. Okay, zombie process, then daemon process. Daemon. The operating system is classified the process into three types: orphan process, zombie process, and daemon. The orphan in the sense, no parent for the child. Due to certain times, the child is always crying for his parent, for her parents, right? But that moment, if someone is not there, even the process, whose process doesn't have a parent default, but even orphan have their own parent called God. Here, God is nothing but system D, right? System D is nothing but PID of one. That's a orphan in the sense a process doesn't have a parents. That's called orphan process. If you ask the context questions, again, you will feel bored. You keep all these questions, you shoot me at the Docker. I will show more practically, right? In which situation you can create the orphan process, right? Next, zombie. What do you mean by zombie? Okay. Okay. If someone attack on you, or am I going to be zombie or you are going to be zombie? Okay. So here, zombie in the CPU point of view, right? There is a parent and child, right? Child is calling the parent. I'm a irresponsible father. I'm not responding to my daughter. So she's crying. She's crying. She's crying for me, right? But due to that moment, I'm busy. Maybe I'm busy with handling the session or maybe handling some calls or maybe I have my own issues, right? Now my baby is going to be cry and cry till the parents are waiting. They are waiting for parent response, but parent is not giving response. Obviously, CPUs, what happens? Kill the child, right? When parent come back, looking at the process control table, then the PID will be lost. Okay, leave it. Let us go for the next. That kind of state is nothing but zombie state, right? And obviously, daemon is always running in the background. You cannot terminate. There are some system processes automatically run. Whenever you install the Linux server operating system, default server operating system is provided the daemon process. If you install some third-party tools like Nginx, HTTPD, Docker, you can create daemons and you can set the daemons in the background, right? Okay. Even though you log out of your session, log out of your terminal, some process is running in the background to keep your application alive. That's called as a daemon process, right? Now the key question is, sir, how can you display all the process in my machine? Then long waiting command is a PS command. PS. If I hit the PS in the current terminal, what are the process attached to this terminal? You will get it. PID, TTY, terminal type. Again, I'm telling PS, if you hit it, the process is attached to the specific or current process running. If you see, man PS. Report the snapshot of the current process. So if you still confused about this description, PS is a command used to display the current process. Current process. Next, for example, I want to display all the process in the sense some application related process, system related process, everything, right? PS minus E, everything, F in a full length format, E for everything, F for full format. Looking at, you got UID, PID, PPID, command, stolen time, terminal, basic time, and what kind of command, right? See, actually, this is something like, I forgot this column. This is the last one is a command. So PID, see looking at PID is 1. That's if you're looking at a command, PS minus EF, such output of the command, hand out to the grep of system D, right? System D, right? So system D, 1, looking at 1, 1, 1, 1, 1, 1, right? This is right. So background, some daemons are also running that we'll discuss later. Some daemons are required, some daemons you don't need to remember it. Leave it, right? So if someone asks you this question, how to identify the particular process exists or not, PS minus EF, pipe symbol, grep of your process name. PS minus EF, PS minus EF, right? Okay. Suppose PS minus U space EC2-user. It means what are the process currently utilizing by the current user, right? If you want to display the process of the current user, PS minus U username. For example, I want to go for custom outputs, right? PS, PS hyphen looking at E for everything in full length format, F hyphen O in the sense custom output, looking at I want PPID, PID, command, and percentage mem in the sense memory, and percentage CPU, right? They'll ask this question, right? Mandatory in the automation script, we use this syntax very effectively, right? I want to display the process whose process are going to have the specific columns. Then you must use -o argument. Then we have to pass the number of columns, right? So percentage memory, percentage CPU, command, PID, PPID. If you go and copy and run this, is that. Let us go with a capital O. Okay, then hyphen EO, right? Everything O. All right. Q. That's wrong. Then can't you give the process ID? Suppose if simply for what you are trying to give it. Give the process ID. For example, I have to give the process ID, right? For example, PS. I'm giving a bash. So if I go with this, the process ID for the bash is 2716. It's saying like a garbage option. Why so garbage option? All right. PS minus EO. All right. I got the PID, comma PPID. Right. What's wrong with you? The CMD. Yes, I got it. Next, percentage mem. All right. Got it, right? Into the percentage with the, is that CPU? CPU. Right. What's wrong? Sometimes it behaves differently. Looking at, right? Perfect. See, looking at PID, PPID, command, percentage memory, percentage CPU. So it gives like how much is CPU and memory consumed by the particular process, right? Please note it down. So they will ask this question to filter maybe spaces issue, PS minus EO, EO, PID, PPID, CMD, percentage mem, percentage CPU. Okay. And also explain the command called PS tree. What is a PS tree? To display the process tree of the specific, like all the process maintained by the operating system. Now see, looking at sudo yum install -y docker. I'm just installing a docker. Right? Then sudo yum install -y Java. I'm installing the Java. So yum in the sense yellow dog update modifier is a kind of tool who are working on the CentOS and Amazon Linux and Red Hat. Even there is a RPM, Red Hat Package Manager. So I'll discuss the 5 to 6 commands are there. I'll show you. Just installing the packages, uninstall the packages, update the packages, upgrade the packages. Sudo yum install -y. What is this? HTTPD is the one kind of web server. You should know it. We'll design it. I mean, design in the sense we'll demonstrate the application through HTTPD. Sudo yum install -y Nginx. Nginx. I've heard about Nginx is also a most powerful web server in the current market. Almost all the companies are using Nginx, right? We need to know that. So what I did here, simply I installed some softwares. Okay, isn't it? Now, if I say PS minus EF of grep of Docker D, am I right? So Docker D end with the daemon, Docker daemon. పిచ్చోళ్ళ ఇప్పుడు చదవంటారు బాబు, అది లైనక్స్లోనే ఉంది అంటారు నేను. Daemon is a background process. When you install the Docker, itself we treat as a daemon, right? So maybe you can call it the Docker. Maybe you can someone may call it as other name. But end of the day, according to the OS point of view, you are only a file to me. You are only my background process, right? That's why now my Docker is running as a daemon. What is the process ID? 2716. The parent process is something like. Run by whom? EC2 user. No, what wrong? What new thing you are learning in the Docker? Nothing. If you know the process management, now immediately you can say, right, suppose if I say Docker PS, what's I looking at? Cannot connect to the Docker daemon. Is Docker daemon is running? It is asking Docker daemon is running. It is saying like, sorry, it is not running. Oh, then I do one thing. Systemctl start Docker. What is this? Failed to start Docker d.service. Access denied in the sense what? No permission. Then what I need to do? See, what is that? Failed to start Docker d.service. What is this? Service. What's saying like? Your Docker d.service not found. These guys are not learn the service management. Blindly they learn some 5 basic commands, right? Okay. See, looking at. See, Nginx is running, right? Process. Now, if you say PS3, now looking at, let me log in as a root user. PS minus EF grep of. Suppose, or I can say, do one thing, PS3. Amazon SSH. There is a one service called as a SSHD. Okay. Now, now it is started. Now, if you go and see PS3, now see, now in the system D, like when I see PS3, from this root, there is a one process is running as a daemon, right? Isn't it? What is this? Container D, Docker D, right? These are the two different processes maintained by the services, right? So process, right? So what I want to demonstrate is don't looking at the Docker, right? If you run anything on the server, the today tip is if you run anything on the server, it is a process. Simple, right? Got it? Huh? Now see PID of sorry, but PID of Docker D. That's why there externally Docker command they will fire it. Internally it is a daemon. Daemon in the sense background services, right? That's why I didn't say like even see exit. I'm going to stop it. Let me close. Let me go to the again connect to the EC2 instance. Connect. Now, if you say, see, I stop and again restart. So services cannot be cannot be killed, but process can stop. Process can be killed. So that's why you should understand the differences between a process and services. Process running in foreground as well as a background, but services always in running in the background. Services I'm not talking. Anyhow, process came. That's why first you need to finish the process. You need to finish the services. Then you need to enter into the SC Linux. Then we'll get clear picture, right? That's why I just gave the notification on the SC Linux, right? So before talking about security, application has its own process, and these processes are managed by the kernel in the foreground and background process. Immediately you will get one more doubt. Sir, from last 1 hour onwards, you are saying like foreground and background, foreground and background. How can you run my application in the foreground? How can you run the program in the background? Can you please? Yes, I will tell you now. Got it? So according to today's concept, process should be run in both foreground and background, right? So how can you run it? How can you run it? Looking at, for this, I'm going to demonstrate simple command. Sleep 10,000. I'm giving like seconds. Normally, if you run any program, if you run any command at the terminal, it is treated as a foreground only. You're executing, right? Executing, right? Suppose if I execute it, see, still it is waiting. It is running, right? Foreground in the sense running, right? Unless until you have to kill it. Control C. Control C stands for kill. According to OS point of view, kill. But మనకు తెలియదు కంట్రోల్ సి, కంట్రోల్ డి, కంట్రోల్ జెడ్, కంట్రోల్ పి, కంట్రోల్ వి, రైట్? Control C here in the Linux operating system, kill the process, right? But before killing it, foreground is always interrupt you or not? Interrupt our execution or not? For that, we have to open and suppose again Shiva or maybe Tejaswini getting one doubt. Sir, I want to run 20 tasks at a time. Is it possible? Yes, I said yes. Then she's asking, how, sir? Then I said, open the 20 terminals, right? Terminal 1, Terminal 2, Terminal 3. Can I open it? But again, she is asking, sir, it is a time-consuming process, even boring process. Every time switching from one terminal to another terminal is more background, more time-taking process. I don't want to do, sir. Then what I do? Keep your process in the background. Keep your process in the background. That's how to keep my process in the background. How to send my task to the background, we'll discuss now. Got it? That's why to keep your program in the background, suppose just attach ampersand. See the output. Don't write. First see it stop us, but given a number and some 3073, right? So that is ampersand in the sense it will stop the current, it won't stop the execution. It will take you to the back to the terminal and move the task to the background, right? Background move చేస్తుంది మీకు program ని. How can you see, sir? The program is like my process is running in the background. Wait, I will tell you. But before that, I'm just running some multiple programs in the background. For demonstration purpose, I'm kept 3 processes in the background. When I use ampersand, at the end without space, first column is looking at first column 1, 2, 3, right? These are called jobs. What is that? So to see the number of jobs running in the background, there is a command called, how many jobs are running? So every job is looking at last one, sleep, command, right? Which program is running in the background? Is it running or so ampersand in the sense what? Ampersand in the sense keep your program in the background process. Now immediately Rahul get one doubt, sir. Anyhow, process is running in the background. I want to take back my background work to the foreground. Suppose task one is working. For that, suddenly a new task is entered. Then what I need to do, I have to keep this task one in the waiting state or my background process, switch to the second process. Once the task is done, you can come back. You take the first and again continue. So how many jobs are running in the background? So I want to take third job to the foreground. Got it? Then see looking at, there is command called, oh, listen first. You can note it down. Anyhow, recording is going on, right? FG, what is a FG? Foreground. What is an argument? 3 in the sense, third job. Now see, it will take you back background task to the foreground. Now, immediately, you have to suspend the current foreground process, again move back, send back to the background. For this, you should press the Control Z. What is that? Control Z. What is the output? Stopped. Now go and see the background. Suppose it is in stop. If you go to the jobs command, see only 2 jobs are running in the background, but one job is in stopped state. Which job is stopped? Third one. Got my point? Very simple, Amma. There is no confusion. Looking at that, so you just focus on the explanation. So if you want to keep your jobs in the background, you should use ampersand. When you use ampersand, the process will be moved to the background along with the job number. Next, to see the how many number of jobs running in the background, there is a command called as a jobs. Next. Now, if you want to get back the background process to the foreground process, so in order to see the execution, right, you should use FG, right? During execution, again, if you want to stop the foreground process and keep your foreground process into the background, you should press Control Z, right? But Control Z is nothing but what? Just stopped. Looking at in the jobs command, third one is see. Now again she's asking, sir, I want to keep my third job is running in the background only, not in stopped state. That movement, there is command called BZ, and what is the job ID? 3. Now see, we go the jobs. Am I right? All third job is running right. Foreground, background. So in the foreground, if you want to stop it, Control Z. Control Z. Once you press the Control Z, it is stopped running in the background. If you want to run stopped jobs in the background, you should use BG, right? That's why here ampersand jobs FZ BG. These are the commands, right? Now, how many jobs are running now? So now if you see jobs -L, like L argument indicates job ID, process ID, right? Now I want to kill either one by one or I want to kill all. Suppose kill all. Kill all is a command. Kill all. What is the command you are going to kill it? Sleep. Or process ID. Kill all in the sense all the processes whose process are running with the command called sleep, right? What is this? Terminated, 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 right? Suppose I don't want to kill all the process, only one process. So kill with the PID. For example, see, sleep, ampersand. Now jobs -L. So there is a one process running in the background as a job. If you want to kill it, kill. What is the job ID? I think so. 30. 935. Now, if you go and see the jobs, nothing is there. So kill with the PID, kill all with the process name, or see, again, one more command. Again, I kept the process in the background. I kept the process in the background. Now jobs-L. Now one job is running in the background as a process. There is a command called as a pkill based on the process name, sleep. So three commands I demonstrated here. One is kill, pkill, kill all. Kill with the PID, process ID. Pkill with the process name. So here kill, you should give the PID. Pkill process name. Here also process name. The difference is you can kill more than one process IDs whose IDs are belongs to a specific process. That moment use kill all. If you don't want to kill all, if you want to kill one by one, there is a kill and a pkill. Get it? Kill, pkill, kill all. Now you should ask one question, right? Why should I kill it? Why should I kill your process? Because due to some heavy stress on the CPU, some process consuming more CPU, more memory, okay, some process are struck, deadlock situations, memory leaks, too much memory is consuming, right? Okay, that moment I have to kill it. For example, some file is occupying, taking more space, then I have to clean up, right? That moment you have to kill it. Sometimes due to some relation between the, even best example, when I simply press Control Alt Del, what happens? Suppose if I try to shut down, what happens? It won't directly shut down. It asks me, right? Hey, some tasks are running. Some tasks are running. Could you please write? Get my point? Huh? Why we need that? Why we need that? Why should I get the confirmation? So that's why. Suppose you want to kill it directly. It means you feel that this is not so essential for you, right? That's why when you are killing, if you want to kill it, you have to understand the dependency. For example, when I try to shut down it, you feel that I have to stop these instances, I have to save my file content, otherwise I lost my data, right? So sometimes, you won't tolerate, no problem, just terminate without thinking anything, right? So it means kill is nothing but internally it will pass a signal to you, right? How operating system close the file, how the operating system close the process. Close the file is different, close the process is different. ఇప్పుడు మనం మాట్లాడుతుంది ఏంటి? Process. How to say that process is killed? How the operating system recognize the process is killed by the kernel? Why? Because it sends one signal to you. What is that? Signal. That's called 9. Signal number 9. What is this signal 9? Looking at. Before stop this option. గుర్తెచ్చుకోవాలి కదా నేను కూడా యాక్చువల్లీ ఐ కాంట్ మెయింటైన్ ద డాక్యుమెంట్ రైట్ మేబీ యు ఆర్ సీయింగ్ మై ఐ డోంట్ ఐఎమ్ కంప్లీట్ ఆపోజిట్ టు సే లైక్ ఓపెన్ ద డాక్యుమెంటేషన్ ఎక్స్ప్లెయిన్ ఐఎమ్ కంప్లీట్లీ దట్స్ నాట్ గుడ్ ఇది మనకి మెయిన్ కదా ఇది ఎంత గుర్తుపెట్టుకుంటే అంత బాగుంటుంది మెమరీ కాబట్టి ఐ హ్యావ్ టు ఆల్వేస్ ఫైట్ ఫర్ ఇట్ సో కిల్ మైనస్ ఎల్ దెర్ ఇస్ ఆర్గ్యుమెంట్ కాల్ ఎల్ ఎల్ ఇస్ a number, right? So looking at there is a, see, internally operating system receive the number 9. Whenever fire the kill, whenever fire the command called kill, internally kernel receive the signal called as a 9 from the CPU. Then kill it. They'll ask this question. So can you kill based on the number 9? Yes, you can also kill it. Got my point? Now see. So signals and traps we'll discuss in the shell script. Just I don't take too much, you'll get confused, but very essential, maybe 20%, 20%, maybe even 5% also, you may not understand, but just how to, trap. What is meant by trap generally? Shiva? Trap the faculty, trap the Shiva, trap the Tejaswini, trap the Rahul Dravid. Huh? So, whenever some errors are encountered, whenever the problems are encountered, when you start the debugging, first I have to trap the errors. I have to trap all errors and I have to check it out, right? That's why there is a beautiful command. Trap is not a command, it's shell built-in command. That's why we'll discuss more. Help trap. Trap the signals and other events, right? Very simple. You only said, right? I want to trap in all the dimensions, right? That's when my program is executing, when my deployment is going on. If deployment is suddenly broken or maybe failure, I want to trap it. First, go and find out what kind of events identified, right? That's what we'll discuss traps. Excellent. Is it clear? So that's why sometimes if the process is not killing, see, sleep. So kill minus 9n, and you can give the sleep also, right? What is that? Sleep argument must be a process. Ah, yes, you're right. What is that ID? 31207. So kill always requires the ID only, not process names. Okay. Now, suppose, I'm sorry. Okay, again I kept into background process. Kill. This time, see, sick kill argument must be process or job ID. What is job ID? Right? Terminated, right? So, kill in the sense terminate. Kill is a command externally. Kill is a command. So when I kill it, it's going to be remove and terminate the process from the process table, and no process IDs are available, right? సో నీ భాషలో టర్మినేట్ నీకు అర్థం అవడానికి కిల్ అనేది కమాండ్ టర్మినేట్ ఇస్ జస్ట్ లైక్ ఏ మెసేజ్ టు ద యూజర్ అక్కడ ఏమొచ్చింది terminated in the sense the process is no longer running. I kill the PID from the process control table. That is the meaning. Kill అనేది కమాండ్ అర్థమవుతుంది కిల్ కమాండ్ ఫైర్ చేసినప్పుడు వచ్చేటువంటి అవుట్పుట్ నీకు అలా కనిపిస్తుంది టర్మినేటెడ్ అని ఎక్కడ సేమ్ ఒకటే కిల్డ్ ఆర్ ఓకే ఇప్పుడు మళ్ళీ దాన్ని రేపు మాట్లాడదా రెండు ఒకటే దాని గురించి డోంట్ గో విత్ ద డిబేట్స్ సేమ్ రైట్ ఓకే కిల్డ్ ఆర్ టర్మినేటెడ్ రైట్ సో వై బికాస్ so what next? So signals, I think so. Good, right? Good to wind up. PID, PID of PS tree, and most powerful command is tomorrow I'll discuss with the next continuation. Process memory map. How much memory I want to, if you want to see how much memory for the process, right? Then we can, for example, PS minus EF. See, what is this? 30 even. When you give the process map, what is this? Something it is given in the Greek language for you, right? In the current moment. Huh? This is a Greek language for you in the current moment. But in the Docker, it become like a Bhagavad Gita to you, right? It become like a supreme commander to you, like. What is this? What is this? U limit. That's a recollect. Yesterday, I give one list to you, right? Open it. Some commands: set UID, set GID, sticky bit, umask. There you can also give U limit. U limit. Most super useful user limits. And suppose your father having a 3 crores rupees as an asset, right? He's giving only limit called as a 5 lakhs up to you married. When he's almost in the last stage, you'll give the complete assets to you, right? So when users are enter into the network environment, Mr. Administrator will set your user limits. How much user limits, like CPU limits? That's why, see, if I say, what is this? Unlimited on Estada. Like expiry date 99,900, like. So that's why unlimited is very dangerous. That's why you mask, you limit. Most typical and interesting and real world uh, scenarios, right? Okay, now suppose see process maps. So pmap is a command. If I give the PID for the bash, internally it will calculate this much memory was occupied. This much memory was given by the operating system, right? Even this is one of the Greek, Latin, German, Japan language to you, right? But who are using performance tuning and optimization SRE, they can understand. But if I say like this, but that's why people, as the Induka command, why the mentor is going to demonstrate that command? PMAP, I said. PMAP in the sense, report memory about the process. Report how much memory the particular process is running in the memory, right? So it has its own structure, right? What is this actually? LC paper, LC collect, LC numeric, I don't know. Simply, if I open this command, what is the purpose of knowing this command? No use, right? That's it. Tomorrow I'll give the twist for you, right? Now you can see blink on your eyes. Ah, that's the reason DevOps engineers are so required for the application performance point of view, right? రేపు చూపిస్తాం మీకు రియల్గా PMAP ఎలా పనిచేస్తుంది, how the troubleshooters are going to deal this, right? Okay, that's it. Tomorrow almost process is over. Tomorrow we'll go with the job scheduling, right? Job schedule AT, ATQ, ATRM, job, and cron job, cron table. Then we will enter into the system performance tuning, right? There I can help you top command, vmstat command, iostat command, htop command. So there are some 10 free command. Yes. So రేపటికి మనం ఇది ప్రాసెస్ మేనేజ్మెంట్ ఆల్మోస్ట్ ఓవర్. కానీ ప్రాసెస్ మేనేజ్మెంట్ అబౌట్ ద సమ్ కీ కాన్సెప్ట్స్ ఆర్ దేర్. సిస్టమ్ మానిటరింగ్లో కొన్ని ఉన్నాయి, అది రేపు చెప్పేస్తాను. ప్లస్ జాబ్ షెడ్యూలింగ్ ఫినిష్ చేసేస్తే సో దట్ 6 modules ఆర్ గోయింగ్ టు బి క్లోజ్. ఓకే, యూ ఆర్ హ్యాపీలీ స్టార్ట్ ద SC Linux ఎక్స్ప్లెయిన్ చేసేసుకుని విల్ స్టార్ట్ ద షెల్ స్క్రిప్ట్. ఇన్ ద షెల్ స్క్రిప్ట్ విల్ ఎక్స్ప్లెయిన్ ద నెట్వర్క్ ఆటోమేషన్, డిస్క్ ఆటోమేషన్, సర్వీస్ వదిలే అనుకున్నావా అవలా ఇంకా కంటిన్యూస్ చెప్తే మీరు బోర్ ఫీల్ అవుతారని జస్ట్ ఐ గేవ్ ద kind of pass. So thank you online. I hope you understand. See you tomorrow at the same time.